So what is the complement of a set? Well, when we've got some set, let's say X, some big set, so that looks like something like this. Let's just call it like a big box. And we've got some A inside it. Let's say that's a little set inside. So A is a subset of X. Okay, so what do I mean by the complement? Well, when I say the complement, I mean all the elements that are in X but not in A. So we write that like X but not in A. It's like a backward slash. So what this means is, say that you're used to seeing complements in the form A, C, or A dash. That's what you might see at GCSE level. Well, in a more general term, you've got some big set or some universe X, you've got some set in it A, and what this X and not A is effectively the same as saying the intersection of X with the complement of A. So X and not A. So that is all of this space that's not in an A. But remember that it is in this set. And usually X is something infinite, something very general, very vast. So that's why we're used to saying not in A. So it can be any element that's not in A. Now, what is an interval? Well, when I say interval, I'm talking about real numbers. So a set of real numbers where you've got all numbers on a line. So you've got this sort of thing where the end point here is A and the end point here is B. Now, an interval is a type of set, but what it does is it includes everything on this line. So it's the interval on the real number line from A to B, and we write this something like A, comma, B. And what this means is every element that you would find that's between A and B. Now let's talk about open and closed intervals. Well, an open interval is actually what I've drawn right here, this curly bracket. So open, well, not curly, yeah, like just like regular brackets if you like. So open is when you have the regular brackets, so A and B, and what that means is that X being an element of the open interval, that means that's the same as saying A is less than X, which is less than B, and notice how these are strict inequalities, so A and B are not included in this set. Whereas closed, that is in square brackets, so A and B, and that means that A is less than or equal to X, which is less than or equal to B. So A and B are in fact included. And you can have something like a half open interval, half closed, whatever you want to call it. So it might look something like normal bracket A and then B with a closed bracket, or A with a closed bracket and then B with a normal bracket. And what that means is, let's have a look at this one first. Well, this one means that A is less than or equal to X, and X is less than, strictly less than B. So whichever one the different type of bracket on, the square bracket or the normal bracket, remember one of them is less than or equal to and one of them is just less than or greater than. Strict inequalities is the point of open and closed intervals. Now let's talk about some infinite sets. These are the most common sets that we use in, well, certainly in higher maths. The first one, the most obvious one, is the set of real numbers, and that is written as like an R, or it looks like an R but like with a little line next to it to look a little bit posh. Like it's hard to draw it, but you see it typed out and it looks really nice. It's like a bold R kind of. The second one that we'll have a look at is the set of integers. These come up quite a lot. This is noted as Z with a little extension kind of thing, and that is just every number that is a whole number, an integer. Another one that we often have a look at is the set of rationals. So the set of rational numbers, and that is written as a Q, like that. So that is any number of the form. So that's the set of A over B, with A and B being integers. So A and B are elements of the set of integers, and the set of rationals is all numbers of the form A over B. So rational numbers. And another common one which you may use is the set of natural numbers, and this is written as N, like that, and that is simply the set of all positive integers. So that is actually equal to integers, but you just take the positive, so you could call it Z plus. And notice that 0 is not a natural number. You have to remember that 0 is not a natural number because 0 is not positive.